It starts quietly. You notice a sound that wasn't there before. Something faint. Something wrong. Maybe a low hum that turned into a grind. Maybe a vibration that got worse every week. Maybe a smell, faint, electrical, that came and went. And then one morning, it stops. You call someone. They come out. They look it over. They run through the checks. And then they say something that will stay with you. It's not worth fixing. Not because it's destroyed. Not because it's beyond saving. But because one part, a single, specific component, has failed in a way that makes the whole machine uneconomical to repair. So you replace it. There was a time when a washing machine was a purchase you made once. Maybe twice in a lifetime, if you were unlucky. They were built like furniture. Solid. Simple. Designed to be taken apart and put back together. You could hand one down to your kids and it would still run. Today, the story looks different. The average lifespan of a washing machine has dropped to somewhere between 5 and 7 years. 5 years. On an appliance that costs hundreds, sometimes over $1,000. So the question worth asking is this: did we forget how to build things that last? Or did something else happen? Because when you look at the evidence closely, this doesn't look like failure. It looks like design. To understand what changed, you need to understand what we had. Washing machines built in the 1960s, 70s, and 80s followed a clear design philosophy. Build it strong. Build it simple. Build it so anyone can fix it. The timer that controlled the wash cycle was mechanical. You could see every stage it moved through. If it broke, you ordered the part from a catalog, paid a few dollars, and replaced it yourself. The bearings that allowed the drum to spin were designed to be accessed, removed, and swapped out. Every major component had a part number. Every part number corresponded to something you could order. The system was modular by design. Nothing was sealed shut without reason. Nothing was buried inside something else just to make it harder to reach. These machines were built to be owned, not leased from a manufacturer on a 5-year replacement cycle. And when something wore out, as things always do, you fixed the thing that wore out. Just that one thing. Not the whole machine. Somewhere along the line, the design philosophy changed. Not all at once. Not overnight. But gradually, decision by decision, the machines we buy today became fundamentally different from the ones our parents had. It starts with materials. Where older machines used heavy-gauge metal components rated for decades of use, modern machines increasingly substitute plastic. Plastic is lighter, cheaper to manufacture, easier to mold into complex shapes, and it wears out. Then there are the electronics. Modern machines don't use mechanical timers anymore. They use digital control boards, microprocessors that manage every stage of the wash cycle. Water temperature, drum speed, load sensing, air diagnostics. These boards are, in many ways, impressive engineering, but they're also fragile in ways a mechanical timer never was. And then there's the most important change of all. The one that most people never notice until they're standing in front of a broken machine. The shift to integrated assemblies. In the old design, every component was individual. You could reach in, pull out the specific part that failed, and replace just that. In the new design, critical components are bonded together, sealed into single units. Not because it makes them more durable, but because it makes them cheaper to assemble at the factory. The consequence is invisible at the point of sale. It only shows up later, when something breaks. Let's talk about bearings. Because bearings are where this story gets specific. These are the small steel rings that allow the drum of a washing machine to spin thousands of times over years of use without grinding itself apart. They're a wear component. They were designed to wear out. Which is why, in older machines, they were designed to be replaced. You could access the bearings directly. Remove them with basic tools. Replace them for under $20 in parts. In many modern machines, the bearings are sealed inside the drum assembly. The drum, the shaft, the bearings, all bonded together into a single molded unit. When the bearings fail, and they will, typically around the 5-year mark, you don't replace the bearings. You replace the entire drum assembly. And that repair can run anywhere from $350 to $600. on a machine that might cost $700 to buy new. At that point, the math does the work for the manufacturer. No one needs to tell you not to repair it. The numbers tell you. And another machine gets replaced. Now add electronics to the equation. Because if the bearing problem is the mechanical failure point, the control board is the electronic one. Every modern washing machine has a main control board. It's the brain of the machine. It decides when to fill, when to heat, when to spin, when to stop. And it's built on consumer electronics-grade components. Not industrial grade. Not built for 15 years of heat, moisture, and vibration. A single power surge can kill it. Sustained heat from a dryer vent too close to the board. Moisture from a slow internal leak. Any of these can cause a failure that makes the entire machine inoperable. Even if the motor is fine. Even if the drum is fine. Even if the pump is fine. And here's where the electronics problem gets worse. Control boards are manufacturer-specific. There is no generic replacement. If your board fails on a machine that's 4 years old, you need the exact board designed for that exact model, which may or may not still be available, because manufacturers typically support a model's spare parts for only a few years after production ends. So even if you want to repair it, even if you're willing to pay, the part might simply not exist anymore. By the time you realize this, you've already missed the window. And the outcome, again, is replacement. Here's where everything that looks like engineering becomes economics. Because none of this is accidental. It's a system. And the system runs on one rule. If a repair costs more than 50% of a replacement, most people won't repair. Industry data consistently shows the tipping point sits somewhere between 50 and 80%. Cross that threshold, and the consumer makes the economically rational choice. They buy new. Manufacturers understand this threshold. They've studied it. They build to it. The machine doesn't need to be designed to fail completely. It just needs to be designed to fail expensively enough. Expensive to diagnose. Expensive to source parts for. Expensive to reassemble. Seal the bearings inside the drum, and you've turned a $20 repair into a $500 one. Discontinue the control board after 3 years of production, and you've turned a fixable machine into a disposable one. The lifespan curve doesn't lie. Machines got better in almost every measurable way, more efficient, quieter, more feature-rich, and shorter-lived. That combination, better in features, shorter in lifespan, is not an engineering accident. It's a business model. This is what engineered failure looks like in practice. Not a machine that falls apart on day one. Not something so obviously broken you can point to it and say, they did this on purpose. It's a machine that runs reliably for 4 or 5 years. Long enough that you think you got your money's worth. Short enough that you're back in the market again before you expect it to be. It's a machine with failure points that are predictable to the people who designed it. Repaired at costs that make replacement more attractive, calculated by the people who priced it. And replaced on a timeline that sustains a continuous revenue cycle for the people who sell it. That's the system. And your 5-year-old washing machine was always going to be part of it. Your washing machine didn't die early by accident. It followed a path. A path built from small choices, about materials, about part access, about component lifespans, that compound into a single, predictable outcome. Replacement. In a system where a product that lasts forever is a product that's only sold once. A product that lasts 5 years is a customer who comes back. On schedule. The patterns in how our products are designed to fail don't stop at washing machines. They run through almost everything we own. Once you start seeing it, you can't unsee it. If you want to keep pulling at that thread, subscribe.